In section 3.2, we're going to begin our discussion of ionic bonding. And in order to do that, let's first talk about ions themselves. Ions are charged atoms, basically, in which the number of protons and electrons are not equal anymore. Remember, in an element, you're going to have equal numbers of pluses and minuses to give you an overall charge of 0. But in an ion, you're going to either have more protons or more electrons, giving you a positive charge if you have more protons, or a negative charge if you have more electrons. Ionic compounds basically have these oppositely charged ions that are going to be strongly bound to each other in what's called an electrostatic attraction. So they're not technically merged together, but they are attracted together strongly enough that they basically move around together. There are two types of the ions. As I said, they can either be positively charged, which we call cations, or negatively charged, which we call anions. And I remember these because a cation has a big plus in the middle of its name. So a cation is positively charged, and an anion is negatively charged. So the cations have fewer electrons than protons. So if you start out with sodium, for example, sodium has 11 protons because it's atomic number 11, and that means that it has 11 electrons because that is required for it to be neutral. So 11 protons and 11 protons and 11 electrons gives you an overall charge of 0. When it forms an ion, it's a metal, so it's going to lose electrons. It actually forms an Na+. So the way that happens is it still has 11 protons, because remember, they always have the same number of protons. That never changes. But it's going to lose one electron. When it loses one electron, it now only has 10 electrons. Used to have 11. Now it only has 10. So 11 pluses and only 10 minuses gives it a +1 charge. So that's how the cation is formed. Chlorine is an example of one that would lose an electron. We're going to talk about that in a minute. Cations can lose 1, 2, or 3 electrons to form a cation, which would give them a +1, a +2, or a +3. And it depends on which atom it is. If you remember in the periodic table that in row 1A is going to form a +1, 2A is going to form +2, and 3A is going to form +3. And what that basically is telling us is you're going to lose 1 electron for sodium and things in group 1A. You'd lose 2 electrons in group 2A, and our example down here is magnesium, right? Magnesium would lose 2, all right? And then, I changed, gosh, I keep hitting this thing, I'm sorry. Let me write it again for you. 2A, 3A, +1, +2, +3. All right, and so that means we lost 1 electron, lost 2 electrons, lost 3 electrons. Okay, so we had magnesium, and it's in group 2A. So it had 12 neutrons and 12 protons and 12 electrons in the element. When it forms an ion, it's going to lose 2 electrons, and so it now only has 10 electrons because it lost 2. So 12 protons and 10 electrons gives it, see, that's what I'm doing, I'm hitting that with my hand, a 2+ charge. All right, so and aluminum is an example of one. It's in group 3A that could form a +3. So now we're at the anion, the chlorine. Chlorine has 17 protons. Remember, it's in group 7A, and everything in group 7A is going to lose 1 electron from the periodic table. It originally had 17 protons, 17 electrons, which gave it a 0 charge. once it loses its, chlorine gains its electron, it's going to have 17 pluses. Really having a lot of trouble with this thing today. It's going to have 18 electrons this time, which means it has one more negative than positives, which gives it a -1 charge. Okay, a -1 charge. So everything in group 7A, chlorine, bromine, iodine, those things are going to have a -1 charge. So metals like sodium and magnesium form the cations because they lose 1, 2, or 3 electrons. That's what is going to have to happen for them to feel like they have a filled outer shell, so 8 electrons in their outer shell. Nonmetals, such as chlorine, form the anions, which are going to gain 1, 2, or 3 electrons to form that and complete their outer shell. Remember, there's an octet rule, and the octet is 8, rule of 8. The octet rule says that the main group element is especially stable when it possesses an octet, or 8 electrons, in its outer shell. So when it has an octet, it has 8 valence electrons, which is just like the noble gases, which have their full shell, which are what these things are going to strive to be. So as I said with chlorine and your group 1, 2, and 3As, they are all going to have similar charges. So if they're in the same group, okay, remember the group is column, then they're going to have the same charge. So 1A is +1, 2A is +2, 3A is +3, and then 6A is going to be a -2, and 7A is going to be a -1. And this is just kind of showing you how the different ones do that. So study this if you want. This is just another way of showing you that group 1A, for example, it's got 1 valence electron, and so it's easier for it to lose 1 than gain 7, so that it has 8 in the outer shell. That's why it forms that. And then group 2A has 2 valence. Group 3A has 3 valence. So see how we're tying how many valence they have to how many they're going to gain or lose in order to form these compounds to be stable. And that's why I was saying earlier when we were talking about valence electrons that those are really the ones that we're looking at, because those are the ones that they're going to either give up, lose, or gain, or share. And so the example for group 6A, you have 6 valence electrons, so 2 of those are unpaired, so those 2 unpaired are going to be the ones that they'll lose to form, or gain, sorry, because here's how I think of this rule, and I'll get to the end of this in just a minute, and I'll tell you how I do this. So this is just showing you +1, +2, +3, and then -3, -2, -1 is how that charge system goes. You do have some with variable charges. These transition metals, some of those can have variable charges, and so that is just going to come with practice and looking at the overall compounds themselves when we get into naming and drawing those compounds, because there's too many of them really to memorize. So don't worry that you're going to have to memorize these. Okay, common ions in the body: calcium, sodium, potassium, chloride, iron, magnesium. A lot of ions are found in the human body. Okay, so we've talked about that. You have group 1A is going to form a +1. Group 2A is +2. 3A, like aluminum, is +3. Then you have 6A is going to form a -2, and group 7A, which are your halogens, is going to form a -1, and then 5A also you can use will be a -3. Okay, so that's the ones that they are going to gain or lose in order to do that. Your ions are very important, as we saw in the body, and so it's important that we know how these things are going to come together and how they are going to stay as stable compounds.